All right, now let's talk about materialized views and specifically how we're going to use them in this modular monolith. So we're going to have a cache. In this case, we're going to use Redis, and we're going to have some system A that needs some data from this cache, right? Maybe it's the address of users. Addresses are in the user module. Maybe the order processing module needs to know the address so it can ship something to the right place. So it's going to make a query to Redis. It's going to say, hey, give me address for this ID. It'll get back the address, and it can continue on and do its job. Now, where do these addresses come from? What if a user adds an address? How does that get into Redis? Well, there's another piece to this. Now, this is where the other system, B we're calling it in this case, is going to be involved. So when a change occurs, it's going to dispatch an event. Anything that's listening to that event will have its handler called. And so when A gets that event, A is going to be responsible for updating Redis. Now Redis will know about that new address, and A can continue to use Redis as its source of truth when it comes to address data. This all works great as long as things are really fast, but what if A needs to get an address and that address isn't in Redis for whatever reason? Maybe Redis just got restarted. And so when it asks Redis for this ID, which should exist because it got sent that ID from some other module in the system, Redis doesn't have it. So A asks Redis for an ID for an address, and Redis comes back with basically a 404. It says, I don't have that. A is going to implement read-through caching. So because it couldn't find it in the cache, it's going to go and read through the cache from the actual source. So in this case, it would use probably Mediator to send a query to system B and get back a result, and along the way, update the cache. So when A makes the query to B, B gives it back a response, and then A updates Redis with the result. This provides a compensating approach for if the events aren't happening fast enough, or if Redis restarts, or some other eventuality occurs, where you want to be able to still get the data from B if you have to, but you don't want to be dependent on B all the time. Now, one last time, just so it's clear, the materialized view pattern like this is much more important in microservices where you're trying to avoid that real-time dependency between A and B, and instead you're trying to make sure that those two systems are isolated from one another at runtime, right? And they only have a decoupled, out-of-process, non-blocking relationship by which those events are updating that materialized view. In the case of the modular monolith, everything's running in the same process. There's much less reason to implement this type of pattern. We're going to show you how to do it anyway, though.